Okay, so what we're doing is we're going to go over sine of 5 pi over 4. And I'm going to show you how to do this by hand. Okay, so sine of 5 pi over 4. I'm going to show you how to do it by hand. Then I'm going to show you how to do it using the unit circle. And then I'm going to show you, and then I'm going to show you using the calculator. Okay, so the very first thing that I do when I see sine of 5 pi over 4 is I graph the angle. So I'm going to come in here, right? And 5 pi over 4. Does anybody know where 5 pi over 4 is? Where's 5 pi over 4? Where's that guy located? Yeah, bottom left. He's here. So he's this angle here, right? So the very first thing you do is you draw your angle, and then you draw your triangle. You just take the elevator up to the x-axis, and then you label your triangle. Because this has a denominator of 4, that tells me that this is a 45, 45, 90 triangle, right? So that means this is labeled as x, x, x root 2. And I'm going to throw negative signs in here because that's the direction I'm going. When I go left, that means negative. When I go down, that means negative. Okay. Okay. And so because this angle is bigger than 90 degrees, we could use our reference angle to find the sine. So what I'm going to do is I'm going to look at this angle in here, and I'm going to do opposite over hypotenuse, which is what sine's definition is. So I get negative x over x root 2. And then you're noticing that those x's divide out. And then so I just get 1, negative 1 over root 2. And so technically that's your answer. But some teachers do not accept this as their answer because this is not rationalized, what they call it. Rationalized means that the denominator has to be not an irrational number, not a radical, not an I, not a log. It has to have just like a whole number. All right, so the way we rationalize it is we multiply by root 2 over 2, which is just my number 1. So I get negative root 2 over 2, because root 2 times root 2 is 2. Root 2 times root 2 is root 4, which is just 2. So there's my answer. Okay. If I was using the, oh shoot, I need to find one. Sorry. Give me 1 second. Let me go grab a unit circle. Okay, so I grabbed a unit circle off the internet. Just Google unit circle. There's tons of them. It doesn't matter which one you use because pretty much they're all going to be right. So the other way to use this is to use the unit circle. I'm going to tell you right now that if you're using the unit circle or if you're memorizing the unit circle, it's the equivalent of using a multiplication table back in like 3rd and 4th grade. There's not a lot of understanding or context, which is why this is my favorite way to do it, by graphing the angle, drawing the triangle, labeling the triangle, and then using SOHCAHTOA, because it gives you a lot of context on why negative root 2 over 2 is my answer. So that being said, if you want to verify your answer, you can use the unit circle. And the way you do it first, and the first couple steps sounds exactly the same. You're going to find the angle, which is this guy right here. And so now we're looking at the coordinates. And because we're looking at sine, you guys have learned, is equivalent to the y coordinate in the unit circle. So I'm just going to grab the y coordinate, which is negative root 2 over 2, and that's exactly what I got over here. So the steps again is find the angle, look at the coordinates, and decide whether you're going to be using cosine, which is the x coordinate, or sine, which is the y coordinate. Okay. Your last little way of doing it is by just plugging in. You got to make sure that you're in the right mode, in radian mode. So it's asking you to find the sine of, what is it? 5 pi over 4. So 5 pi over 4. And then there's your answer. This is the problem with the calculator. Your answer, negative 707, is the equivalent of negative square root of 2 over 2. It's the equivalent of it. But see how I cannot get this answer? This is called my exact answer from the calculator. I can't get that. So just be mindful of that. So yes, this is right. So I just want to show you, if you did this right here, go ahead and take a second and make sure that you have 7 pi over 4 down. Use whichever way makes the most sense to you. But try this way because it's going to help you out a lot in our next chapter when we're solving the equations. Because then I'm going to have you go backwards and I'm going to say, hey, find me the angle whose sine is negative root 2 over 2. And you'll be able to come up with the answers quicker than if you were to use, say, your cosine, I mean, your unit circle or whatever. Okay, now that you're back, sine is 7 pi over 4. I'm just going to practice with you again. So the very first thing I want you to do is graph the angle. And 7 pi over 4 to me this is 4 pi over 4, right? And then so to get to 7 pi over 4, it's going to be right here. And the reason why it's right here is because the whole thing, if I went all the way around, it would have been 8 pi over 4. And then you took a pi off, a slice of pizza off. And so now you don't have 8 slices, you have 7 slices. Does that make sense? So there's 7 pi over 4. So you draw your angle, draw your triangle. We already know we're still in the 45, 45, 90 triangle. So then I would label my angle, my triangles rather. So this is x, negative x because I went down, right? And this would be x root 2. And sine, again, is opposite over hypotenuse. So this is negative x over x root 2. And you're like, hey, Ms. Johnson, that's the same answer. Yes, very good. Oops. Yeah. And you're like, Ms. Johnson, these are the same. That makes sense, though, right? Because they are on the same y level. They're the same y level down. These two triangles, even though they don't look like it because Ms. Johnson doesn't draw very well, but these two triangles are reflections of each other. Do you guys see that? So let's see if you could find it here on the unit circle. So here you're looking at 7 pi over 4, which is this guy here. Right? And then which coordinate are you looking at, the x or the y? Very good. You're looking at the y. And then the next question, I don't know if you saw the next question, is why are the answers both negative? It's because, I don't know, you guys tell me, why are both answers negative? Why are both of these answers negative? Very good, because both of them are moving in the y direction down, which means negative. Very good. So the reason why I like doing it this way is because that answer comes off so much easier than you going and doing this here, right? Which again will help you when you're solving these trig functions. Okay, very good.